So differentiation property, that is time differentiation property, the statement is like this: Laplace transform of f dash of t or d by dt of f of t is s into f of s minus f of 0. So now here I have wrote this some complete statement, one time differentiation operation, right? One time differentiation operation. Now if the differentiation operation is number of times is increases in time domain, then the standard statement we have to prepare here. So for that purpose, now I am writing the standard analysis. See, Laplace transform of f of t, n times derivated means n times differentiated, n times differentiated, f of t whole to the power of n I have wrote here. That means this is differentiated n times. So in time domain n times differentiated, immediately in frequency domain this f of s multiplies with s to the power of n, and later we have to write initial conditions. Those initial conditions are like this: minus s to the power of n minus 1 into f dash of 0 minus s to the power of n minus 2 into f of 0 dash, and so on. Up to we have to write f of n minus 1. So this initial condition differentiated n minus 1 times here, right? One simple representation I am writing like this. Now Laplace transform of d square f of t by dt square, d square f of t by dt square. That means f of t function differentiated 2 times. So in time domain this f of t function differentiated by 2 times, then frequency domain this f of s multiplies with s square, right? Here one time differentiated s is multiplies, in 2 time differentiated s square multiplies, n time differentiated s to the power of n multiplies, right? So s square into f of s minus s power is decreases, s power is decreases. So s to the power of 1 into f of 0, f of 0 is initial condition, minus s to the power of 0, right? So here s square is there and here s to the power of 1, and later it gives the s to the power of 0, s to the power of 0 is 1, right? So then write 1 into f of 0 dash. So for 2 times differentiation in time domain, then in frequency domain this gives the equation. So s square into f of s minus s into f of 0 minus f dash of 0. F dash explains the differentiation operation of these initial conditions. Similarly, if the differentiation in time domain increases, here this s power is decreases and this initial condition number of terms also increases. That's why here I wrote the standard equation: s to the power of n into f of s minus s to the power of n minus 1 into f of 0, s to the power of n minus 2 into f dash of 0, and so on up to f to the power of n minus 1, 0. F of 0 explains the initial conditions. All these are initial conditions. If suppose the function does not consist any initial conditions, assume this complete part is 0, then we have to write only this function here, right? So this explains the time differentiation property, and similarly here we have to discuss frequency differentiation property. Frequency differentiation property, right? See, from the time differentiation property here I want to write one simple statement here. The statement is: in one domain differentiation operation, another domain it multiplies with the domain factor, right? So please observe the statement here. So in one domain means here time domain. In time domain differentiation operation, in other domain is nothing but here frequency domain. In frequency domain, it multiplies with the domain factor. So here we are discussing 2 domains. One is time domain function and another is frequency domain function. From these two, in any one domain, differentiation operation applies. In other domain, it multiplies with the domain factor. So here f of t is differentiated. Your frequency domain multiplies with which factor here? S, because your frequency domain factor is S. From this, now I want to write one statement like this: Laplace transform of f of t is f of s. Laplace transform of f of t is f of s. Now I want to apply differentiation operation in frequency domain. In frequency domain, the domain factor is s, so that's why here I want to differentiate this f of s with respect to s. So this side differentiation applies, then immediately in time domain it multiplies with this domain factor. This domain is here which domain? time domain, so t multiplies here, but minus symbol it gives here. Right? See, this side differentiation, here t multiplies. In time domain differentiation, here s multiplies. That's it. Simple statement. In one domain differentiation operation, in other domain, it multiplies with the domain factor. So in time domain differentiation differentiation operation, in frequency domain it multiplies with s. In frequency domain differentiation operation, in time domain it multiplies with t. So other domain it multiplies with the domain factor. Now from this, I want to write a Laplace transform of nth power. So t to the power of n into f of t. That means this f of t multiplied with t n times. N times it multiplies. Then this side it becomes like this, minus 1 whole to the power of n into n times differentiation f of s. Okay, this is the standard statement of frequency differentiation property. Now we have to prove this one. See, to prove this purpose, again I am taking basic Laplace transform equation. F of s is equal to integration from 0 to infinity f of t into e to the power of minus st dt. So basic Laplace transform equation I am taking now. Apply both sides differentiation. Apply differentiation on both sides, right? On both sides with respect to s. So differentiate the complete expression with respect to s. Then the function becomes here d by ds of f of s. D by ds of f of s is, the integration is changes from 0 to infinity. This side also we have to apply integration. But this function is f of t function. But here we are applying integration, differentiation with respect to s. So apply differentiation with respect to s. So this is differentiated e to the power of minus st into minus t into dt. See, this side differentiated d by ds of f of s is equal to integration from 0 to infinity f of t function independent of s. So write f of t as it is and differentiate this term with respect to s. E to the power of minus st is e to the power of minus st into minus t, because here differentiation with respect to s is there. So into minus t dt. Right? Now the complete function becomes like this. Integration from 0 to infinity. This minus symbol I am writing this side now. Minus d by ds of f of s is equal to integration from 0 to infinity. This t multiplies here t into f of t into e to the power of minus st dt. Right? From the Laplace transform basic equations, this e to the power of minus st into dt multiplies with any one function. This is acts as Laplace transform of this function. So from that directly I am writing now Laplace transform of t into f of t is, Laplace transform of t into f of t is minus d by ds of f of s. So this is the standard statement of frequency differentiation property. Frequency differentiation property, time differentiation property. The differentiation property standard statement is, if the differentiation operation applies in one domain, in other domain that multiplies with the domain factor. So differentiation operation in time domain, in frequency domain it multiplies with s. If the differentiation operation in frequency domain, in time domain this multiplies with t. So one side differentiation operation, another side multiplication. So this property is also comes under multiplication by t. So this is also one of the very important property. So please take this now.